Hello everyone. In this session, we learn about how neural networks learn from the data. Learning in neural networks. So, learning in neural networks refers to the process of adjusting the network's weights and biases so that it can make a better predictions. As we know, neural networks, let us take a small example. Here I have one neural network of 3 layers: input layer, hidden layer and output layer. Input layer takes the features of a data set, and hidden layer process, and output layer we predict whether what is the output of that particular task. In this one, generally input features are we make a sum of weights or weighted sum, and we apply a activation function that activates which neuron has highest probability to get activated. Means activation function decides which neuron to fire. So like this we adjust the forward propagation we apply from starting input layer to output layer. Weights are adjusted. Finally we predict what is output. If output doesn't match with the actual output, so we readjust these weights and biases. Again our model will learn from the data. So how this model learns from the data? We have 3 types of learning techniques: supervised learning, unsupervised learning and reinforcement learning. Supervised learning means network learns from labeled data. Labeled data means here we give some features to the network. Suppose I have to classify whether in an image there is a cat or dog. So here I tell the network what are the features of a cat and what are the features of a dog. By learning the features of a cat, it finally gives the output. It finally classifies the output whether a given image belongs to cat image or dog image. Now this kind of we are giving some feedback to the network or some label data to the network. We call it as a supervised learning. Your network is learning with label data. Second kind of a learning technique is unsupervised learning. In unsupervised there are no labels. Network finds its own patterns in the data. Means here we don't give any explicit classes like the output should belong to only cat and dog, and these are the features. Here we are not giving, model itself is learning from the data. Third one, reinforcement learning. Reinforcement learning is nothing but your model is interacting with the environment. So nothing but is a learning by example. So in the reinforcement learning, by looking at the environment's current state with compare its previous version of that environment's state, it learns what should it act in that environment. Like learning by example, this kind of environment, reinforcement learning. These are 3 basic techniques of learning: supervised, unsupervised and reinforcement learning. So here learning means actually our neural network getting trained on the features of the data. So when we go for a training process, there are some terms involved here. First step is input data like images, text and numbers. We send it to the network. Here first input layer takes images, text and everything. Next one, forward propagation. The data passes through the layers of the network. Each layer performs mathematical operations using weights and biases. Here I told you. First this layer gives its input and weights. Output of this layer is sent to the second layer. Output of this layer sent to the next layer. Like that forward propagation is done. Forward data flows from this state to the output state. Third component, loss calculation. The output is compared with the actual target using a loss function. The loss tells how far the prediction is from the truth. So here after getting the output we calculate the loss. suppose today if I take one example, like there is a forecasting, weather forecasting. I predicted that whether today there is a rain or not by looking at some features and their weights. If this is the feature with that weight, what would be the activation, which neuron will activate it, like that. So finally, what I predict whether there will be rain or not, what I do, I compare with the prediction with the actual one. So I calculate the loss. Suppose I take one example. Suppose there is an image here. That image let us work out. Suppose there is a rectangle, output may be a rectangle or circle. So by looking at the features of rectangle, my features are sent to the input layer, weights are calculated for each feature, and with this direction it is forward propagation is done. Now output either it should be a rectangle or circle. So training on the features it is not a perfect always, means there may be some miscalculations, means some corrupted weights we may have given to the network. So there is some error. Suppose it is predicted as a circle, actually shape is a rectangle, here I got it as a circle. So now I calculate loss, how much loss is there between this actual prediction, this prediction and desired prediction. That loss is calculated, error, how much error is there. So completely there is a lot of error. Sometimes there may be a prediction may be near to the rectangle, that way error may be a less. This error is again back propagated to the network. It says that which weight has contributed to get this loss. So we adjust those weights again in the direction back propagated. The loss calculation, we call it weights that contributed to the error are readjusted. We call this process as a gradient descent. So this one, first we performed a forward propagation, then I checked the loss calculation, I performed loss calculation. If there is error, I forward that, I propagated that error back into the network. The network calculates gradient of the loss with respect to each weight, means how a weight contributed to the error, that each individual weight that is partially that is differentiated, means we make a slight adjustment to that weight and again recheck whether this is giving correct output or not. This tells the network how to adjust each weight to reduce the loss. So process of weights update, we call it a gradient descent using an optimizer, like the network updates the weights to minimize the loss. So there are some techniques, Adam technique, SGD technique, that help us how to perform this gradient descent. So repeat these 2 to 5 steps until over many data samples and iterations. So like this we stop this process of readjusting the weights when we reach the correct output, means where we get minimum error, least error, and there is no change in that error. At that stop, we stop the process of learning. So in forward propagation, we calculate a formula, Z equal W into X plus BA, weights and biases. So this Z is taken into activation that decides which neurons has ability to learn from the data. X is the input vector, W is the weight vector, B is the bias, Z is the weighted sum. After forward propagation, we use this activation functions. These activation functions help us in deciding the neurons that has ability to fire for a particular scenario, like which has a context. So ReLU, sigmoid, tanh, and softmax are some activation functions that give either 0 to 1 values that help us in guiding activating the neurons. We go through this in our next sessions, how this activation function execute. Next one, loss function. For classification types, we take the formula of calculating how much loss is there. We measure this y log y, where y is the true label, y dash is the predicted from the one. If you are applying a regression, means finding a relation between dependent and independence variable, we apply this common loss function, mean squared error 1 by n into summation of y minus y bar whole square to measure the loss. I told you back propagation, gradient, how we update the weights. Once the weights are updated, W equal to W minus n into loss with respect to each weight. We perform these three optimal stochastic gradient descent, adaptive moment estimation, and RMS techniques to perform this gradient descent. And the last one, when we have a large data set which are given as input to the model has to process this data in a series of epochs. Epochs means one full pass through the entire training data set while learning from the data. One full pass we treat as one epoch. A subset of training data used in one update step, we call it as a batch. So balance, efficiency and stability, we call it as a mini batch gradient descent. So these are terms used while training the data set. So here basically we have three kinds of a learning: supervised, unsupervised and reinforcement. Each learning has its own task, like classification algorithms, they use the supervised learning. Clustering algorithms, they go for unsupervised learning. So game playing adversary applications, they go for reinforcement learning, where two opponents they play with each other. They choose this one of them, and these are the steps we forward in a training. First input, forward loss, back propagation, wait, update, repeat. So in our next session, we go across what is activation function, how it helps us in learning the data set. So we do some calculations using loss functions, and what is a gradient descent in our next session. Thank you.